Let's get started. Hey, everyone. Welcome. I'm Rebecca Slider, and I'm an engineering director here at Etsy. Welcome to Code as Craft. So the Code as Craft speaker series is a really integral part of Etsy engineering culture. Since our first talk back in 2010, we've had technologists from all different parts of the industry joining us to present on just a bunch of different technical topics. Sorry. In organizing these events, I've had the pleasure of hearing from folks about the different ways that Etsy and really Code as Craft have impacted their careers. So if you're interested in hearing more about that, I'm interested in meeting you. Come find me after tonight's talk. Which brings me to our talk. Keyur has been at Etsy for 8 years, where he's worked on practically every single engineering problem we faced. He's now Etsy's chief architect, putting his years of experience to use as we build for the future. Most recently, he's been focused on ensuring the success of our migration to Google Cloud Platform, which began in late 2017. But enough from me. Without further ado, please join me in welcoming Keyur.
Thanks, Rebecca. So I'm Keyur. I am here to talk about the migration of the monolith that powers Etsy.com to GCP. And we have to do it in about 8 months. So really fast. So why was that? As Rebecca said, we signed the Google contract in December of 2017. For the most part for roughly the fall of 2017, we did an extensive vendor selection process, and Google was the one that won out. And we signed the contract, and our leadership had decided that we would not extend our data center contract, the first of which would expire in August of 2019. So this gave us about 20 months to get the monolith working in the cloud. And this is because the monolith, as it has existed for a decade, and it cannot survive in just one of our remaining data centers. So we really had to get moving on figuring out what we would do when this DC shut down. And it was actually not even really 20 months, because the intervening period, we're an e-commerce site, we have 4 months where there are it's a period of high traffic, and we avoid making large infrastructural changes. So really it was 2 periods of 8 months, and we were hoping to avoid the second period because there would be no give in the timeline if we drifted into that. We wanted to get it done in the first 8-month period, so in case we failed, we would have another 8 months to try again later. So a little bit about Etsy before I go too deep. We're the global marketplace for unique and creative goods. There are about 60 million items on the site, 2.2 million sellers, and 41 million buyers. The vast majority of our sellers identify as women, and they're running their businesses from home, and our business is of one. And coming to the tech, Etsy has a lot of homegrown tech. You may have heard of a little demon called StatsD that we'd released maybe I don't know, a decade ago. Some of you may even use it. And we've open sourced a bunch more tools since then, like Deploynator that we use for deploying our monolith over 30 times a day. We have a lot of tools that we haven't open sourced, like our in-house data center provisioning system, our MVC platform on which we build the monolith, our ORM, database failover management, and things like that. A lot of it has grown organically as the site, as we've needed to develop new capabilities to manage all of our systems. The monolith itself is a fairly straightforward LAMP application, and I say straightforward, but really it looks a little bit like this. There is a lot of code added over the years, held together by some glue and sticks and things like that. And we have a bunch of monolithic shards. Our database is sharded, but we tend to treat it as a one entity. The ORM hides some of the complexity there, so people don't actually, developers may not always be aware that it is sharded, and a whole bunch of caching to just speed things up. But the good thing of being a LAMP stack is that it's actually relatively easy to scale. So there is a load balancer, there are some web servers, and then some more load balancers, some more stateless, that's important, web servers, and then eventually ending up in a pool of databases or caches. And we've been able to scale this for years with very little or very little systemic issues. So in 2013, Etsy started the process of moving to an API-driven development framework. The reason at that time was primarily because we had started building our first mobile apps, and we needed to render complex views and return the data to our clients in a fast manner. And PHP is single-threaded. There was no good way to do like coroutines or multi-processing within a single request. So what we came up with was a framework for wrapping curl calls, basically making multiple HTTP requests, multiple child HTTP requests in order to render a response. And over time, like this became how we did development even on the web stack. So for example, if you landed on the Etsy.com homepage, there might be a bunch of modules on it, like your favorites, your friends' activities, things from our blog, recommendations that we may want to show you. So the single request for the homepage is decomposed into like 4 requests that may be further decomposed to like actually fetch the data from a database. And this pattern has allowed us to like independently scale every aspect of the system without needing to like just scale the web servers that are actually rendering the page. So the API servers are able to like handle the traffic. We're able to insert maybe indirection, like some caching and things like that in order to handle load. And in the past, like we were data center focused. Like this timeline would be familiar to folks who run in a DC. Like you sort of budget 6 to 12 months out. You place your order like a quarter before you need it. Then you receive it, you rack and stack it, you build it, and deploy it. And like there are some like well-known downsides of this. If you order too little, like you have to shuffle things around. That may not always be easy, and it was definitely not easy at Etsy. Or if you order too much, like the hardware sat idle. So when we had decided to move to the cloud, sort of the key points that, or the key benefits that we were looking for were to have the ability to like reach for enormous amounts of compute when we needed it. The elasticity aspect was also critical because we're actually doing a lot of machine learning and data science work where we need to spin up thousands of cores, do some processing, spin them down, and not have them just sitting there all the time. And efficiency, being able to like, we have sustainability goals for our company, so not keeping the servers running all the time was really important for us as well. So with that, how on earth do we actually like migrate a 10-year-old monolith to the cloud? So remember, this was our timeline. We had 2 periods of 8 months. We set ourselves a bunch of ground rules. So we wouldn't make any large architectural changes when we're doing the migration. We wanted to minimize the risk. Like this was already something that was super risky from like the company's standpoint, and we didn't want to introduce more change than was needed. We would migrate the fewest systems needed to make the site work in the cloud, and all of the time, like we need to be compliant with SOX and PCI and any other regulatory obligations that we have as a public company. So we looked at a few options, a few design options to like make this happen. The first was a read replica. So Etsy.com, like maybe the right side of it continues to run in our data center, but we spin up a copy for maybe say signed out users that runs in GCP and start to redirect traffic to them over there and gain confidence. But unfortunately, like given the way that our monolith has been built, it expects strong data consistency, and we could not guarantee that our signed out users would have a good experience. So we had to shelve this. The other option was to do active data centers, where maybe like traffic from the West Coast goes to a GCP region in the West Coast, and traffic from the East stays in our New Jersey data center. But even this, like again, was not something that we could do because we're a global marketplace. We have the strong internal consistency issue that I'd mentioned before, and we didn't feel like it was worthwhile for us to refactor the application in order to support this architecture. So eventually, we sort of latched onto a lift and shift. we are like, it was a lamp stack. It was something that we understood very well. We had operated for years, and we felt that we could pull this one off. But what that meant was we actually had to do something that most people in today's like e-commerce age do not do. We had to take the site down uh, in order to effect the cutover. Um, we realized that we had to proactively communicate with all of our customers that the site would be going down for a period of a few hours, and then it would come up in GCP, hopefully faster, better than it was, and sort of like do a lot of planning and expectation setting, both internally and externally, to like make this a success. So to paint like a timeline, in December 2017, like we had the partnership, and we sort of set ourselves a goal of like cutting over by August, mid-August, so that we would have enough time to hit Thanksgiving and Cyber Monday with confidence. So how did we approach this from a like organizational perspective? We spun up what is like we called it a migration squad. So the reason for that is our systems engineering organization that manages all of the infrastructure for us. It's split up and it is functionally partitioned into things like compute, which provides like fleet management and resources for doing like computational stuff, observability for monitoring, storage for databases and caches and things like that. Deployments, traffic, like you get the gist from the names. But all of these teams had their own roadmaps and their own on-call responsibilities, and they were still responsible for keeping the data center going. Like they could not pivot to focusing solely on the migration. And we wanted to unblock the engineers on these teams to like move as fast as possible in order to meet our timeline. So what we ended up doing was we pulled a few engineers from every team together into a squad. We took away all of their other responsibilities and had them focus solely on getting the monolith running in GCP. So once we had like the squad running and they were like starting to try things out, we had to work with a whole new set of tools. As I'd mentioned before, like a lot of the tooling for infrastructure at Etsy was homegrown, but one of the advantages that we now had was we could rely on open source tooling that has been out there and put out there by other companies that we could use. But we had to learn how to use that. So as an example, like we use Terraform as our infrastructure as code platform. And one of the like funny things there is if you change a string, like a description of an internal load balancer, it actually destroys the load balancer, essentially, I guess, taking your service off the internet before bringing it back up with a new name or a new description in our case. So it was things like these subtle gotchas of basically immutable infrastructure that we had to learn and figure out how to work with and work around. Another thing was dependency management. We had technical project managers who had to figure out all of the sort of dependencies that we had never really like paid attention to between product teams and infrastructure teams and the various like features that are on the site to figure out that we had good coverage for testing and that we had support from other parts of engineering to like make this a success. And performance. In our data center, we had hyper-optimized for performance. Like every box, our ops teams in the past had like created custom SKUs in order to get the best bang for buck. But in GCP, like there are no custom SKUs. It's all like you get a handful of choices and that's it. And we had no idea like what to expect in terms of performance. So as like we were sort of figuring all of this out, we entered like this load and testing and functional testing phases. We had a lot of engineers from the company like sign up to do bug bashes to like go onto our test site in GCP and test it out, see what's breaking, see what doesn't work, and open bug reports for us to like debug, open firewall rules and things like that. And also we set up a whole bunch of like load testing bots that would hammer the test site so that we could figure out the performance story. So as an example, like we had some projections for traffic for holiday season 2018. We made sure that our bots like were double sort of our projections, just so we had enough confidence going in to the holidays. And like funnily enough, even in the cloud, like CPU architecture really matters. In the data center, like we paid a lot of attention to this, and in the cloud we discovered that Google by default would give you the oldest CPU if you don't ask for the newest CPU. And the performance was noticeably different. Like Skylakes were like 10, 15% faster in our use cases, and it made like the performance story a lot better once we discovered this. The other sort of interesting observation was that Google's network runs at like a ginormous scale, and when they promise 99.99% SLA, like that can still mean not good enough performance for our application. So as an example, their global load balancer had a performance issue that only affected 0.01% of packets, but it was enough that we could notice it in our graphs where our test traffic would see latencies in many second range rather than in the millisecond range. The great thing is like Google was really awesome about it. They like with the data that we gave them, they triaged it, they debugged it, and they fixed the issue. But it's like you got to watch out for these things. And while we were doing all of this, we sort of had in like the best outage of my career. So we had set up, like we had done enough testing that we had started to stage things for an eventual cutover. And one of the things that we had staged was a DNS entry in one of our DNS providers for our GCP endpoint. This particular DNS provider did not support the do not serve flag. So we had set it up with a weight of 0. And then as things happened, once after we had done that, a few weeks later, our site had an outage. And it went down in the data center. And the DNS provider started serving our GCP record to our real users. And they landed on a test site. The site had data that was many months old. It had a blue banner rather than a usual Etsy orange and things like that. And people were really confused. But luckily for us, like if the rest of the infrastructure was not scaled enough, so the GCP like copy fell over immediately. And our users did not have an enormously confusing experience. But this was a good learning for us. Like we figured out some like weird dependencies in our system, and the engineer most proximate to it like won the Etsy 3M Sweater Award for 2018. So coming to the actual cutover. So roughly we had picked a Sunday, which was the lowest traffic time of the week for us. It would be early Sunday morning, so like 3 to 7 a.m. And our development teams were alerted that like we would be entering a soft freeze starting Wednesday, so like no major code changes, and then a hard freeze for the weekend, and another soft freeze like post cutover, assuming the cutover went smoothly. So cutover day arrived. We had a lot of excitement internally. There were like 60 plus engineers on site at 3 a.m. to help us do this. And this was the rough plan of action. Like we would start at 3 a.m. We would turn off Etsy.com in the data center. We budgeted 90 minutes to do that. And then another 90 minutes for validation and testing in GCP, and then ramp up real user traffic starting 6 a.m. So turning off Etsy in the data center, it's been running there for over a decade. There are lots of things that we did not expect or know what would happen when we turned them off. So we had done a bunch of planning, we'd created these giant Excel sheets of the order of the things to do, what could be parallelized, what could not be parallelized. And this actually worked out really well. Even with all the moving parts, the site went down and sort of quiesced perfectly on schedule. And then we were able to create a copy, a final snapshot of our data, ship it to GCP, and bring back all of the data, the databases and other stateful things in GCP. And at 4:30, roughly on schedule, we were able to start validation and testing. So our internal users, they updated their DNS and they were able to hit GCP. And we started to bring back crons and other asynchronous processing. And that's when we hit our first issue. Like we ran out of memory on a particularly important set of boxes, and which we had not discovered during testing. Uh, our testing had focused on the top 80% use case, like most things that users would see, and some of our key, like asynchronous processing stuff, but not everything. And we could not figure this out. It was 4:30 or 5 in the morning. We were all really tired, having been up all night, and we gave up. We rolled back. Um, we didn't feel confident that we could cut over safely and give our users a good experience starting at 6 a.m. Uh, so the next day, like on Monday, we all came into the office. And we started digging into this issue. And remember, like we only had like all of August to like do this. Otherwise, we would have to wait until January. Um, Luckily, like we had like a lot of people pitched in, and we figured out what the issue was. We figured out a few other things, and on Wednesday, like we thought we had a good enough handle on things to like try again, because otherwise it would be a long wait. Systems would drift, and then we would have to wait till February or something to like try again. It didn't feel super great, so we convinced ourselves that we could do this, and we should try again. So we did. The key difference in the second attempt was we started earlier. So we started 1 a.m. and we gave ourselves a lot more time to do validation and testing so that if when the unexpected thing happened, we had time to respond and react and fix it. So we again turned off the site in the data center. This went really smoothly. We had gotten very good at this. We had turned it back. We turned it off and turned it back on already. So that went very well. And then we entered the testing phase. And again, we ran into unexpected issues. This time we had, like the thing that happened was remember how I had said we only moved the absolutely necessary systems to GCP. So one of the things we hadn't moved was our LDAP servers. They were still in the data center, which was 25 milliseconds round trip time away. And we do a lot of sudoing in our crons. And that caused the crons to back up because the latency meant that sudo couldn't respond fast enough, and the local caching daemon like couldn't keep up. So we had to bump the number of threads in order to get unblocked. And these crons are really important to our site. In another case, we had too many threads that was causing contention. We were running bind. Bind by default attaches to every core on your system. We had a 96 core box running bind, and bind did not do well. We had to artificially lower it to 4 cores in order to get DNS performing in a reasonable manner. But like, because we had given ourselves enough time, like we got through these issues. We were able to fix them on the fly as they came up, and we were able to validate and test all of the sort of different and most critical flows to gain confidence that the GCP environment was correct. So at about 5:30-ish a.m., like we started to ramp our users back in. Like we did it slowly, 1%, 5%, 10%, eventually landing at 100, and we were live. We watched a lot of graphs. We were all there doing so, making sure that the site was stable, that the error rate and performance was like good. And then we had to sort of make this key decision, like should we stay or should we go back? Going back would be the safer option. We've been there forever. But if we stayed, we would learn a lot more. We had already sort of reached the limits of what we could learn from synthetic testing. Because all of the things that we ran into that night, like we had not come across them in any of our testing. Like none of us had even thought of these things. So as a group, like we decided to stay and learn more over the course of a few weeks, and then make a call for like Cyber Week. There were like some metrics that we were watching, that we were going to watch for the next few weeks in order to like make a informed decision about what to do. So things like performance regressions, impact on our sales, operability of the new platform. Like if it was super noisy and pagey, we didn't want the people getting the pages to suffer for the next many months. But actually, it was all right. Like it worked out pretty well. So this is a performance graph The two sort of blank spots there are two cutover windows when the site was down. And the performance was quite all right in GCP. Like it's all the way to the right. It's a little bit slower, but it was within our error bounds. And we felt that this gave us enough confidence to actually continue to stay on GCP. So as I'd said before, like we still had a bunch of things to do. We had to tune our systems. All of our configuration was best optimized for like the hardware profiles that we had, and we discovered like more things as we continued to run in GCP. As an example, system calls are really like not. I shouldn't say really. Like they're slower than they're on-prem. On-prem, we were running bare metal boxes. No virtualization, whereas on GCP there is at least 2, if not 3 levels of virtualization, and every like context switch to do a system call is slower. We measured up to 10% slower. So we figured that we spent a bunch of time optimizing that away, like smoothing out like a bunch of performance spikes that we were seeing. Another issue that we ran into was around mutexes for MySQL. Remember how I had said that we decided to use Skylakes? This was an interesting surprise because in Skylake, Intel changed the behavior of one of the instructions and made it 100 times slower. The instruction is really important for a spin lock, and what it meant in practice was that mutexes and spin locks got extremely contentious when running in a large I guess, multi-threaded context, and MySQL got really bogged down at times, so much so that it would fall over. We had to sort of figure this out on the fly. Luckily, MySQL has a lot of flags, so we were able to turn this behavior off and tune it in a way that it continued to work with reasonable performance. And later, we discovered the Skylake instruction thing, and actually, Oracle is putting out a patch soon to fix this. Another thing was network performance was again a little bit surprising. For our memcache nodes, and we do a lot of caching, we realized that at extremely the tail ends of latencies, there were small spikes of unpredictable performance, and we had to carefully tune all of our timeouts and all of our buffers to sort of smooth this out and reduce the performance spikes for our users. And so roughly this is the full timeline. So by the end of by roughly October, we thought we were in a good spot. We had tuned everything enough for Cyber Week, and performance was in a good place that we could enter the busy period with confidence. And we did. We have been running in GCP for 9+ months. It's been mostly smooth, and it actually worked out. So some observations. About running in Google. So Google does this thing called line migrations. They're really cool, where they will move your workload from one physical host to another seamlessly with a small blip of a few tens of milliseconds when they want to do maintenance on the server, upgrade their virtualization layer, fix the security bug or whatever. And this is really great as compared to other cloud providers where you don't have to take down your service yourself. Google just does this for you. And it's been awesome. We've not had to deal with any of the Spectre fixes or any of the more recent Intel things. They have just been fixed beneath us without us noticing in most cases. But the thing is the cloud really infinite? I don't know. Not really, at least when you do it at scale. So we had to be really communicative with Google about our capacity requirements. We could not just spin up 10,000 cores to do a thing because they would sometimes not have them. So this is not the promise or the dream of the cloud, but when you do it at large enough scale, you need to you still have to treat it seriously and be really open about your needs with your cloud provider, something that we had to learn. And a sort of really bad sort of outcome that we had to figure out and fix was long-lived network flows. In the data center, we had these connections that could live for weeks, months, because they were persistent and they gave us like a performance boost. But in Google, like if the network connection is idle for 10 minutes, it will tear it down. And it will tear it down in a very like unfriendly manner, in a way that the application cannot actually detect. So we found this in a few cases after like a few days even that this was happening, and then we had to scramble to figure out and fix it. And there is no actual fix from the Google side. This is all things that we had to do because this is how their SDN works. So like coming to like the close, so we've been running for 9+ months. We have a bunch of like interesting work that we're currently doing to like situate better in the cloud. So we did a lift and shift. We didn't really like do a cloud native architecture or any such thing, but those are things that we actually think we want to do now. So some examples of projects, like we're actually actively working on Vitess. Vitess is a database clustering solution that was developed at YouTube and solves horizontal scaling. So we have a team that is exploring doing this, like putting this in front of our MySQL clusters to ease management and failover and replication and all of these things that we previously did not even have. Another team is working on auto-scaling. The lift and shift approach also meant that we did not really end up doing this. We had configured our clusters in a static manner through Terraform, and we scale them up and down basically like humans scale them up and down. But we want to get better at this so that we're able to adopt to like traffic loads and sort of keep only the minimum set of number of boxes needed to like manage to keep the site up. So there are like interesting problems in this space. How do you use Prometheus? Like, do we use GKE? How do we do configuration management for the hosts? All of these things that we need to figure out. And regional fault tolerance. Occasionally, cloud providers have an outage of a full region, and we don't want Etsy.com to suffer when that eventually happens. So we want to make sure that we're well prepared for this eventuality. And operational structures. So we want to look into like SRE, like if that is the right practice for Etsy, and what does that mean? How do we adopt it? And how do we like migrate from or move what we're doing into this new model? Does the Google model fit Etsy well? Don't know. Those are things that we're trying to answer right now. So if any of those like sound interesting to you, like we're hiring, come talk to us. There are a bunch of Etsyans in the audience who can tell you more about the culture, the work, and the company. With that, thank you, and I will take questions. There is a mic here, if you could please come up to that for the people on the live stream.
Where did your data centers used to be? Physical data centers?
I'm sorry, can you repeat
Your
that?
physical data centers before you migrated to a GCP, where did they used to be?
What did they use?
Like what data centers where were you?
I don't know if we publicly stated this.
I mean,
I'm
you're not
sure.
there anymore.
Well, we actually
Okay.
still are. So like I said, we're shutting down our first data center this year. So we're still actually
Or
there.
at least like what provider?
I actually was weirdly cautioned not to mention this already.
All right.
So I'm sorry.
Okay.
I can't answer that.
I have a general question about how would you do it if you had to do it again, or are you preparing to move again? Are you change something if you ever have to move again? And the question came from when you said you've reached the limits of what synthetic testing would let you test when you're trying to decide where to cut off or not. After having done it, have you learned something you could have done at that point to test better, or are you testing better now?
So actually, like, my opinion about the lift and shift hasn't changed. So like I would still do like this approach rather than a re-architecture. In terms of testing, I mean, more testing can be good. And we definitely, found like some gaps in areas that did not have enough like dashboards or sort of institutional knowledge that we had to build along the way. But I don't know like how I guess in hindsight, that is apparent to me. I don't know how I would have known that beforehand. Because like a lot of systems that we run like have been there for ages, and the people who build them like may not be here. We may not have up-to-date documentation and things like that. So it was really hard to surface those without running into them first. Now we know, so it should be easier the next time.
So that was the other part. It's like, are you doing something now to prepare for 5 years from now moving to, I don't know, Apple Cloud or?
I mean, we're definitely, I guess, as an organization, like documenting better. Like we've been. I mean, most companies try to do this anyway, so we try it in our own way. And we're trying to like avoid siloing of knowledge, not having single points of failures in terms of humans, things like that. Like process changes to like make sure that we don't lose information over time. Hopefully that works for the eventual migration to Apple Cloud.
On the lift and shift step, how did you transmit? How did you go from the data on the database, serialize or store, transmit, and restore it? Like, how did that process work? And what data size are we talking about? Thanks.
Sure. So we have about 1,000 shards. Each of them is about 2 or 3 terabytes. So the way that we migrated the data was we took a snapshot, an extra backup of the MySQL database, shipped it to GCS, and then downloaded it onto like a bunch of nodes in GCP, and set up replication to like keep it fresh. And because like we had a lot of lead time, the DBAs were able to do this like months in advance of our testing, so that they were able to like build their tools to like gain confidence in their setup. And streaming, like the replication stream meant that we didn't have to do it again. We only did it once, the giant data copy, and then the data was copying all of the time. Yeah. And like a couple of like interesting things I can add, like we use Google persistent SSDs as our like underlying storage layer, which has this like neat feature of doing snapshots. So we've relied on that to create more copies of our data, where we snapshot a disk and restore it onto a new VM. MySQL does its crash recovery and comes back up ready to go. So that's how like we spun up the test copy of Etsy.com in GCP that we didn't want our users to see.
I was just wondering, now that you have the web monolith in the cloud, is the long-term plan for it to remain a monolith, or do you intend to refactor, decouple, or?
I mean, yeah, I think over the years, like we will refactor and decouple. It's not a super high priority for us. Like there are some really nice aspects to the monolith. Like we have a lot of tooling to monitor it, to deploy it, and institutional knowledge about how it works. So sort of a service decomposition like is not a priority for us. It's the direction that we would like to move in over time as like projects or opportunities arise to like pull something away. Like we would like to do that, but we're not approaching it as like a directive from top down.
Thanks.
Have you been using any of Google's managed services? Like you mentioned that you were using their load balancers and then GCS. Are there any others that you moved with this process or have adopted since? And are you hitting any issues with those?
So in terms of the monolith, we don't use a lot of managed services yet because it's mostly like commodity like software, MySQL, PHP, Memcache, and we didn't think there was much to gain, at least initially, from like using Google products. Especially like some of their things in this space may not be like as mature as we would like. But in other domains like big data, like we're using a lot more managed services. So we use Dataproc, we're using a lot of Bigtable, but that wasn't covered by my talk. I'm hoping that there will be another talk about that. Yeah, because just to preview that a little bit, like that area did not do a lift and shift. They did a full re-architecture to like use Google managed services.
When you were looking at architectural options, you didn't consider moving only a subset of your users to the cloud and to gain experience before you move the whole user base?
So we did. So like the active data center essentially like is that, right? Like,
Okay.
and because of our application expecting really strong data consistency, we didn't feel confident that that would work.
I see.
Over the years, like, and to like shed more light on that, like, the way that the app has evolved is we've come to rely on extremely low latency access to a memcache. And once we had to cross like a 25 milli like round trip, that was just not viable.
Okay. Okay, thank you.
Hi, I work here, so I was around, but not really. I had like a great 8 hours of sleep, and then I woke up, and then we were on the cloud, which was cool. But I'm wondering, like, for you all, like, what was the emotion, and also, did that kind of hinder your ability to make decisions because you were like, we're either doing this or we're not for 5 more months. So like, so what was that like?
That's a good question. So the first time that we had to roll back, like we were super bummed because we'd worked on it for so long, and then the fact that we couldn't figure out the issue because we were all so tired was not great. But I mean, at the end of the day, like the way, like we had written down a set of criteria for like continuing to move forward in our action plan or rolling back. So we relied on that, like on prior written material rather than being like emotionally driven on the spot. And we had people who were project managers who were maybe in this room who ensured that we followed like what we had said we would do.
Hey, I just wanted to ask a little bit about your process choosing providers and yeah, what your thinking was, what drove you to Google, and then I know you mentioned that your data team is sort of using some of their managed services. Are there other things that drew you to the Google Cloud for that?
Yes, so I will like, so we have a blog post actually about how we chose a provider. Sort of like quick summary is we had a large Excel sheet of capability, like our requirements from the cloud provider that we assigned scores for, and we use that decision matrix to like guide our thinking. Our CTO, Mike Fisher, has written an even longer explanation of that, of like how we arrived at Google Cloud. In terms of like other systems that we're running in GCP, like we are, so like our search stack and our machine learning stack are on Kubernetes, GKE, Google's managed Kubernetes offering, and that is also not a lift and shift, like they've re-architected to like fit that model, and hopefully they will, those teams, if you're here, they should also talk about it publicly. Yeah, and I hope we do. Great, thank you.